Hello everyone, this is Mr. Nice Guy, and in this video you'll learn how to fold paper and prove Pythagoras theorem in the process. Yay! First, you will need a piece of paper, not just any paper, a square piece of paper. Step 1. Fold the square piece of paper into half like this. You should get a rectangle, not a triangle. Here, a rectangle. Step 2. Fold the paper into half again. And you should get a shape with 4 equal sides, otherwise known as a square. Step 3. Can you see this open side of the square as well as the closed side or the center of the original paper? Fold along it and you should get a triangle. Ta-da! Step 4. Identify the edge of the triangle where the center of the paper is and fold it down. It doesn't matter how much you are folding it down by. More than half is also alright, since this is actually a general proof of Pythagoras theorem. Step 5. Open the paper and you should be able to see your square piece of paper like the and a square in the middle. Step 6. Now you will need to fold along the small square, and if you have a friend called a long ruler, it will be very useful to you right now. So fold along like this. So fold and open. The next side, fold and open. And do this for 2 more times. Now your paper will look something like this. 8 rectangles and 8 squares. To help us with our next step, you will need to draw a triangle here. So take out a pen and draw the vertical line, the hypotenuse, and the horizontal line to get a right angle triangle. Step 7, which is also the most difficult step, fold the paper down along the hypotenuse. A ruler would be very useful. Repeat this 3 more times. And you should get this. 4 triangles and a square in the center. If you open your piece of paper, you should get a pattern like this. 4 congruent triangles and a square in the middle. If you cannot see them, let me draw the 4 lines of the square out. Ta-da! So with this, we can prove why adding the square of the height to the square of the base of a right angle triangle is equals to the square of the hypotenuse, which is a fancy way of saying a square plus b square is equals to c square. First, let us call the shorter side b and the longer side a. The hypotenuse, let's call it c. Now you should be able to see that the length of a side of the big square is equals to a plus b. Since the length here is a and the length here is actually the shorter side of the other triangle, which is b. Hence the area of the big square will be bracket a plus b square. Unless you are blind, you should be able to see that the whole big square is made up of a small square and 4 congruent triangles. So area of the big square is equals to area of the small square plus area of the 4 triangles. Area of the small square is c square, since its length is the hypotenuse of the triangle, while area of the triangle is half base times height, which is half times AB. And because there are 4 triangles, we need to multiply it by 4. So this equation we have right here is basically saying area of the big square is equals to area of small square plus total area of the 4 triangles. If we simplify it, the left hand side will be a square plus 2ab plus b squared. For the right hand side, c square will still be c squared, while half ab times 4 is equals to 2ab. Minus 2ab from both sides of the equation, and we will get 2a squared plus b squared is equals to c squared. Ta-da! Well done to me. Pythagoras theorem shown. And this will work for all right angle triangles. However, there is another way. Remember the other side of the square before you open your folding? Bing! Here we also have a big square, which is made up of 4 triangles and a small square. The 4 triangle, if you haven't realized, has the same base and height as the earlier example. So the longer side is A, while the shorter side is B, and the hypotenuse is of course C. In this example, area of the big square is equals to C square, and is equals to the total area of the 4 triangle plus the area of the small square. Area of the 4 triangle, as we found out earlier, is 2AB. Now, you may want to pause this video to think about what is the length of the small square.
Have a break. Have a Kit Kat.
If your answer is A minus B, dang, 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 you are right. Because the length of the square is the length of the triangle minus away the base of the triangle. So the equation we have right here will be C squared equals to 2AB plus bracket A minus B squared. If we expand out the right hand side, the bracket A minus B squared, it will give us A squared minus 2AB plus B squared. Simplify it and we will get C squared is equals to A squared plus B squared. Wow, Pythagoras theorem shown. Well done to me again and have a nice day. Bye bye.